Assalamualaikum and a very good day to you all. In this video, I would like to continue with the fourth example of Lagrange multiplier. Okay, so the first step is to state what is the objective function and the constraint function. Now, what we want is to find the minimum and the maximum values. Okay, so so we have to find everything lah. Okay. So we have to optimize objective function. What is the objective function? Objective function, this one. Okay, so objective function being fxy equals x cubed plus 4y cubed. Okay, and then the constraint function is given by x plus y minus 6 equals 0. Okay, and then since we are using Lagrange multiplier method, okay, so the second step is to come up with the big F of x, y, and lambda. Okay, so it's given by x cubed plus 4y cubed plus lambda bracket x plus y minus 6. Okay, and then the third step is finding the partial differentiation f sub x. Okay, so what we have is 3x squared plus lambda, the second one with respect to y, so we have 12y squared plus lambda. And then last but not least, f sub lambda is x plus y minus 6. And then the fourth step is letting each one of the partial differentiations equals to 0. Okay, so let f sub x equals 0, f sub y equals 0, and f sub lambda equals 0. Okay, so 3x squared plus lambda 0, 12y squared plus lambda 0, and then x plus y minus 6 equals 0. And then step number 5 is to solve for x, y, and lambda. Okay, in order to do that, we have these three equations. We might as well perform a simultaneous equation. Okay, so this one can become rearrange them to become lambda equals minus 3x squared. This one lambda equals minus 12y squared. Okay, so this one equals each other, so minus 3x squared equals minus 12y squared. And then we can potong some more. X squared equals 4 correct. Okay, so you see over there something easy shown already. So x equals we rearrange them to become 6 minus y. Correct. Okay, now you see this one x also, we can substitute. So we bring this 6 minus y, substitute inside the square, and then equals 4y squared. Okay, now expand lah. 36 minus 12y plus y squared equals 4y squared. Correct. And then bring the 4y squared together. 36 minus 12y minus 3y squared equals 0. And then I rearrange it nicely, and then I potong while we can. So what we have is y squared, nantilah, minus y squared minus 4y, potong 3 berapa? 12. Okay, that one, and then make it positive. Yes, like that. Okay, now can simplify or not? Can lah. Y 12, 3, 4, 6, 2, 2. Correct. Okay, so what we have is y equals minus 6, y equals 2. Okay, now to put here lah. Okay, now y know already, x is this one, right? Okay, bring there. So x is 6 minus y. Correct. Okay, 6 minus y. Now what is y now? Minus 6. So 12. Okay, now how about lambda? Lambda, take this one lah, smaller. Okay, lambda is minus 3x squared. Correct. Betul. Okay, what is x? X is 12. Okay, so 144 minus 144 minus 3 minus 432. Okay, so the first stationary point is 12 minus 6 minus 432. Okay, and now for the second one, x equals 6 minus 2, which is 4. Correct. 6 minus 6 minus y. 6 minus y. Correct. Okay, and then we continue with lambda. Lambda equals minus 3x squared. What is x? X is 4. Okay, 4, 16, 16, 3, 64 kan? 16, 3, 64. 48 lah. 16, 3. Okay. 48. Okay, now the second stationary point is 4, 2 minus 48. Okay, now, so this is what? 6 step. 6 step. Correct lah. I give 6 step or 7 step? Forgot. Correct lah. State first. Okay. Okay. So, what are the stationary points? 12 minus 6 minus 4, 3, 2. And 4, 2 minus 48 are the stationary points. Okay, are the stationary points. Okay, now what is the 7th step? Okay, 7th step, remember, we substitute whatever the question wants. Okay, in this case, unlike the previous examples, the question wants the minimum and the maximum values. That's why I use the word optimize over here. Okay, because we want all the extremes. Okay, we want the highest one, we want the highest one, we want the smallest one also. So what we do, we just substitute each stationary points inside the objective function. The objective function is f. Allah Akbar, forgot lah. Forgot lah lately. Where's the function? Oh, this one. Copy paste lah. Copy. Okay, copy. Okay, and then paste. See, this is more. Okay, so this is our objective function. Okay, this is our stationary point. What to do? Just substitute. So add 12 minus 6 minus 4, 3, 2. Okay, the f is 12 minus 6 equals 12 cubed plus 4 minus 6, 3. And then use your beloved calculator. Okay, so 12 cube plus 4 minus 6 cube also, right? So we get 864. Okay, and then add, we do over here lah. Okay, 2 minus 48. Okay, so the f 4, 2 is 4 cube plus 4, 2 cube. Okay, correct. Yeah, so 4 and this one is 2. So we have 96. Okay, now unlike the previous example, this one we get, okay, now the values is 864 and the other is 96. Now this one is not like the previous typical differentiation that you've learned in first semester. whereby if it's positive, it's minimum. If it's negative, it's it's a maximum. Okay, it is not, because what we do now is we take the stationary points and then we put into the objective functions, and then what we get here is the values. Okay, this is the values. So the values can be two, maximum or minimum. Now, which one is maximum, which one is minimum? It is relative. It means that we have to compare with the other to know whether it's a maximum or minimum. So when we compare the yellow one with the blue one, so 864 is the bigger one, the larger number. So if it's bigger one, so this is the maximum value. So the maximum value is 864. Okay, and then this question also wants the minimum value, kan? Okay, so write also the minimum value is 96. Okay, so in Lagrange multiplier, you don't have to easily intimidated or get confused. Okay, because just follow the steps. Okay, you get until step number 6, you get the stationary points, and then right away substitute all the stationary points that you get inside the objective function, and then you compare. Okay, you compare each other. Okay, sometimes maybe the number is 864 and then this one minus 96. Okay, so one positive, one negative. Maybe we logically think, oh, the negative is smallest one, so this is the minimum, this is the maximum. Now, how about if this one is negative, this one also negative? Okay, so for sure this one is the minimum. Okay, if other question lah, and then you get the values like this. Okay, and this one become the maximum. Okay, so it is relative. You have to compare with the other value from other stationary points. Okay, to conclude whether the value or the points is the maximum or the minimum. Okay, I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.